this is Mrs. Bullen with your Unit 11 review. We'll start with the warm-up. The first question here, because there is nothing between the parentheses, I know that that's a multiplication problem. If I were supposed to add or subtract, there would be a plus or a minus, but because the parentheses are touching, that means multiplication. There's lots of different ways to do these problems. I'm going to go ahead and stick with the box method. X plus 1. So x times x is x squared. X times 1 is 1x, or you could just write an x. And then x times -3 would be -3x, and -3 times 1 is -3. So if I'm going to write this in standard form, I would put the x squared, -3 plus 1, so 3 minuses and 1 positive. I have 2 negatives left over, so -2x, and then I copy the -3. So that's the answer for that one. Remember, you should be trying these problems first and then check your answer with the video, and you can put me on pause anytime you want, speed me up to 2x, and I could. All right, so we're going to distribute this one. Again, if it's touching the parentheses, that means we're multiplying. So 2x times x to the 4th would be 2x to the 5th. 2x times 4x would be -8x squared. We multiply the big numbers, and then we count up how many x's. And that is it for this one. Okay, next question. I'm going to put together like terms because there is a plus in the middle. So that means I can ignore the parentheses. So I'm going to put -3x and +5x, and I'm going to get +2x, because think about this. If I have 1, 2, 3, 4, 5 positives, 3 negatives, I have 2 positives left over. And then I'm going to do the same thing with the +1 and the -8. So I have a +1 and a -8. So if I had 8 little negatives, 5, 6, 7, 8, and 1 little positive, 1 would cancel off. I would still have 7 negatives left. So 2x minus 7. So we're going to look at problem number 4. This one, unfortunately, has a subtract problem. And so that subtraction applies to everything that follows it. So maybe you guys remember from middle school, keep, change, where we keep everything the same from that first one. Nothing's happening to the beginning here. So I'm just going to write t squared plus 4t to the 3rd. Then we're going to change this to an addition problem. We're going to add the next two things. So if I add a -5t squared, that's like doing -5t squared, or you can think negative times positive is a negative. Then I have negative times a positive is a negative. So keep, change. That changes to a -t. And then we're going to combine like terms. I start with the highest exponent, which would be that 4t to the 3rd. Then I go to my things that are the same. T squared take away 5t squared, which would leave me with -4t squared. And then I just have that -t at the end. So that is your answer for the 4th problem on the warm-up. Hopefully you guys did okay on those. Now we are going to review all of chapter 11, which was factoring. So first we're going to factor the greatest common factor out of both of these. And so I'm going to write them as a product of everything that's listed there so that we can see what they have in common. So this first one, I'm going to write the x squared as x times x. The 4, I'm going to write as 2 times 2 because I know that I have a 2 in my first problem, and I know that they have that in common. And then the x to the 6, I'm going to write out 1, 2, 3, 4, 5, 6 x's. So now I'm going to circle everything they have in common. Okay, so there's a 2 in each one. I can't circle both of those though, because the most that I could take out from both of them is just one of the 2's. It has to be whatever I take from one, I have to take from the other. It has to be the same. It's kind of like when we're reducing fractions. Whatever we do to the top, you have to do to the bottom. Okay, then I'm going to say, well, I can also take 2 x's here. Well, then I could take 2 x's here. So I'm going to take those things and I'm going to put them out in the front of the parentheses. So I'm factoring them out. So I have 2, and then x times x is x squared. Well, here's something interesting. I've taken everything out of that first term. So essentially what we're doing is we're dividing it out. So if I have 2x squared divided by 2x squared, that just equals 1. When things cancel out with division, it doesn't equal 0, it equals 1, okay? Then we copy the minus, and then we see what we have left. There's a 2 right there. And then we're going to count how many x's. 1, 2, 3, 4 x's are still left behind. And that would be my answer. Okay. Question number 2. Factor out the greatest common monomial. So the biggest single term that goes into all 3 of them this time. Well, this one has a 6 and a 7, and this one doesn't even have a number. So there aren't really any numbers I can pull out, but I notice they all have at least one R. So I'm going to put the R out in front, and then I'm going to put what's left. If I had 4 R's and I took one of them out, I would have 3 R's left. If I have 7, that 7 stays there. I had 2 R's. I'm taking one of them out front. So there's going to be 1 left behind. That 6 just stays there because I'm not pulling out a number. I had 1 R and I moved it out front. So I don't have any R's left for that one. That's all I had to do on that problem. Okay, question number 3, factor out the greatest common monomial. So I'm going to look at these and I'm going to say, I like to start with the littlest number. And I'm going to say, does this littlest number go into the other 2? Yeah, it goes in 8 times and it goes in 9 times. So I know right away that I'm going to be able to take out a 6. The next thing I'm going to do is I'm going to say, well, what's the most number of B's that I can pull out? I can't pull out 6 because this one only has 4. I can't pull out 4 because this one only has 2. The most that they have in common would be 2 of them. And this is me pulling it out of all of them. In case you're wondering, I'm like not just doing chin-ups here. Okay, so I'm going to pull out 2 of the B's from each of those terms because that's the most that goes into all of them. Okay, so let's see what's left. I had 54 and I divided by 6. So that would leave me with 9. 6 times 9 is 54. Then I had 6 B's and I took 2 of them out. So I would have 4 left. I'm going to copy the minus. 48 divided by 6 is 8, right? Because if I multiply it back out, I want to get that answer. And then I had 4 B's. I took 2 of them out. So I have 2 left. So B to the 2. And then 6B squared. And I took out 6B squared. Remember, when we divide it out, the same thing divided by itself is always 1. So we put a 1 there so that when I multiply it back out, it keeps that value. Okay, question number 4. Write a trinomial whose terms have a greatest common factor of 2x. So trinomial means 3 things. So I'm going to start out with an 8x to the 3rd. Then I'm going to put a 6x squared. And then I'm going to put a 4x. Because the biggest thing that can go into all of those would be 2. And then they all share 1x. So that's just mine. Yours might look different. That's okay. As long as the biggest thing that can go into all of them is 2. And the most x's you could pull out would be 1. So one of your terms has to have only 1x. They all have to be even numbers, but not numbers that something bigger could also go into. So that's a little bit tricky. Okay, question number 5. We're going to factor this. So I always have my students write the parentheses first, put a K in each one. Because this is negative, I'm multiplying to make a negative. I know the signs have to be opposites. So I'm going to put a plus and a minus. I know I have to have one of each. So I'm already like a good ways there. Now I just have to figure out the numbers. So we're going to start with that negative 48. And I'm going to say all the things that go into it. 1 can, 2 can like the bird. 3 can, I think. Yeah, 1, 6, 16 times. 4 can. Wow, a lot of things can go into 48. 5 cannot. 6 can. 7 cannot. 8 can, but it's already on my list. Okay, so looking at my answer right here, I know I'm trying to add them together to get a negative 2. So if the answer is going to be negative, I know that the minus has to stick to all my bigger numbers. So then I'm just looking for what has a difference of 2. Well, it would be that one right there. So I'm going to put the 6 next to the plus. I'm going to put the 8 next to the minus. And that's my answer. Okay, question number 6. We're going to go ahead and set this one up the same way. I have my in, and in. This tells me the signs have to be the same. So I either have to have a plus plus or a minus minus in order to multiply to get a positive at the end. But if I have to add up to make a negative 9, there aren't any positive numbers that are going to add up to make negative 9. So I know they both have to be minuses. So minus minus. So now I'm going to list all the things that make 18. 1 can go in, 2 can go in, 3 can go in, 4 cannot, 5 cannot, 6 can, but it's already on my list, so I know I'm done. So now we're going to put minuses on everything. You get a minus, and you get a minus. Just kidding. And now we're going to see which adds up to make -9. Well, -3 and -6 make -9, so I'm going to put the 3 and the 6 in my answer. That's it. Super easy, right? Okay. Oh, number 7's way easier because it's all positive. So looking at number 7, I'm going to put my parentheses. I'm going to put an X in each one. I know it's going to go plus and plus. You might be looking right now at the 14 and be like, that's 2 times 7. That makes 9. I know my answer. Fill it in. Okay. But if you're stuck, what you can always do is make a little list of what goes into 14. I know that 1 always can. 2 can, because it's 2 can again, because it's a positive number. 3, 4, 5, 6, none of those can. 7 can, but it's already on the list. So it stays, everything's positive. This is the sum that makes 9. So we put the 2 and the 7. Again, this list is only if you look at the problem and you're like, I'm not really sure. Okay, if you can see it right away in your head, like for this one, I know 4 times 5 makes 20. And if I subtract them, I get -1, depending on which one's positive, which one's negative. So for me, I wouldn't even write the list. But sometimes if you're just stumped on a problem, it's a really good place to start. Okay, so let's look at number 8. Then we're going to write the parentheses. I'm going to put an X. I'm going to put, remember this is a negative. So in order to multiply to make a negative, I have to have a positive times a negative. It doesn't matter which one's first. Okay, so I have the -20 and I need to multiply. So 1 can go in, 2 can go in, 3 can't, 4 can, 5 can, but it's already on the list. And then because the answer is negative, I know that all the bigger numbers have to have the negative with it. So this is the one that makes -1. The 5 goes by the minus, the 4 goes by the plus. Okay, question number 9. Remember, this is one that I talked about, I think in yesterday in our Unit 10 review. This is the same type of thing, but I want you guys to think about it like this. If I have 0 x's there, I know that it needs to multiply to make 4, but it's going to cancel each other out. Okay, they're going to add up and make 0 x's. So if I list all the things that make -4, that would be 1 and 4 and 2 and 2. And if I try to find what makes 0, it'd be +2 and -2. So I'm going to write x plus 2, x minus 2. Okay. Question number 10, there's also a shortcut for this, you guys. Anytime it's called difference of squares. Anytime you have something squared minus something else squared, right? 4 you could rewrite as 2 squared. Anytime you have two things that are squared, you know it's going to be the square root of the first one and the square root of the second one with a plus, one with a minus. So like if it was 25, I'd put a 5 here. If it was 49, I'd put a 7 here. One with a plus, one with a minus. Okay, because that's what's going to cancel out is when they're the same but opposite signs. Next factoring one. Again, we've got our parentheses. We put an M in each one. I know the signs are going to be the same, plus, plus, or minus, minus, but it has to add up to make a -6. So I know I'm going to have 2 minuses there. So I'm going to make my little chart for 9s, 1 and 9, 3 and 3. It's a short chart. And everything's going to get a minus. So that is my only possibility. That will give me -6. And that is your answer. You could also write it a little bit simpler. Anytime we have something times itself, we could write it as that factor squared. Okay. Next one, we have number 11. The area of a rectangle is this. Its length is this. Find the width. Well, remember, area is length times width. So I know I'm just looking for what multiplies by it to make that answer. So I know one of the answers is x plus 8. I know that it has to be a minus right here, so x minus. So what would I multiply to make 48 with 8? 8 times what makes 48? 6, and then you can check it. If I add those up, do I get +2? Yes. So this part right here is my answer, the x minus 6. Okay, question number 12, determine if the equation is true for all values of x right, true, or false. Okay, let's just try plugging in any value. Let's try plugging in 5 or even 1. Okay, if I plug in a 1 right there, 1 is probably the easiest number to plug in. So if I plug in 1, I get 1 squared. So 1 squared plus 25 would be 26. And over here, if I plug in 1, 1 plus 5 first and then square it, well, 1 plus 5 is 6. So 26 equals 36. False. Okay, it would be true if you're plugging in 0, but that's about it. Oops, sorry. That is your notes for your Unit 11 review.